This is the final video in the course. We're going to cover the key standards and frameworks that formalize what we've discussed, identify the specific resources you should bookmark and return to, and give you 4 specific actions to take this week in your actual environment. Then we'll close out. Several documents belong on your radar. You don't need to memorize them. You need to know that they exist, understand roughly what each one covers, and know when to refer to them. NIST publication NIST SP 800-82, the Guide to Industrial Control System Security, is the most accessible starting point. It's published by the National Institute of Standards and Technology. It's comprehensive, authoritative, and free to download. It covers everything from asset management to incident response in an ICS context and is a useful reference for any OT security conversation or assessment. The NIST Cybersecurity Framework, CSF, is a broader organizational framework that many industrial organizations use to structure their security programs. Where 800-82 is technical and ICS specific, the CSF provides a high-level structure: identify, protect, detect, respond, recover, that maps security activities to business functions. Many regulatory bodies and insurance underwriters now ask about CSF alignment. ISA IEC 62443 is the primary international standard for ICS security. This is the standard referenced in most formal OT security assessments and certifications. The Purdue model we covered in Module 4 is embedded within this framework. If you're involved in system design, procurement, or security certification for OT environments, ISA IEC 62443 is the standard your work will be measured against. CISA, or the Cybersecurity and Infrastructure Security Agency, publishes Industrial Control System Advisories online. These advisories cover well-known vulnerabilities in specific industrial products: Siemens PLCs, Schneider Electric Equipment, Rockwell Automation Systems, and others. If you operate any ICS product, check whether CISA has issued an advisory for your specific product and firmware version. New advisories are published frequently. NERC CIP, the North American Electric Reliability Corporation Critical Infrastructure Protection Standard, applies specifically to bulk electric system operators in North America. If your facility generates, transmits, or distributes electricity above the threshold NERC defines, NERC CIP compliance is mandatory. The standard has specific requirements for electronic security perimeters, remote access, and change management that aligns directly with what we've covered in this course. 4 specific things to do this week, not someday, this week. First, check your IP address documentation. Sit down with whatever asset inventory exists for your OT network, a spreadsheet, a list, a diagram, and ask whether it's complete and current. Does it include every device you can physically see on the floor? When was it last verified? Is there a device on the network that isn't in the list? 1 hour invested in this question tells you whether your visibility is real or assumed. Second thing to do this week: find one Telnet-enabled device on your OT network and start the conversation about replacing it with SSH. Don't try to solve all of them at once. One device, one conversation with the vendor or the engineering team. Get a timeline for when it can be addressed. That's one fewer plain text remote access path that existed compared to yesterday. Third, look up one CISA advisory for a product you operate. Go to their website, search for it, search for a vendor name you recognize, read the advisory, get familiar with the format, the affected product, the vulnerability description, the severity score, the recommended mitigation. This is the information source that tells you when your equipment has a known security problem, and the only way to act on it is to be monitoring it. The 4th thing to do this week: go ask your primary OT vendor how they connect remotely. Is it through an always-on VPN or session-based? Who requests the access and who approves it? Is MFA required? Is the activity logged? The answers to these 4 questions tell you your current supply chain risk exposure. If the answers aren't what they should be, you now have specific technical language to have that conversation with the vendor. You came into this course with experience operating SCADA systems and industrial control equipment. You're leaving with a specific understanding of how the networks underneath those systems work, and why the way they're designed, configured, and maintained determines how defensible they are. You understand how IP addresses and subnets define who can reach what. You understand how protocols and ports define what attack surface each device presents. You understand how VLANs, DMZs, and firewall rules create the layered architecture that contains breaches and limits blast radius. You understand how to see what's on your network, what traffic patterns are normal, and what anomalies look like. And you understand how real attacks move through these environments and which controls stop them at each step. That's a different set of capabilities than you had before Module 1. The concepts in this course give you the foundation to participate in security conversations about your environment, to evaluate vendor recommendations critically, to identify misconfigurations and architectural weaknesses, and to understand why security requirements exist rather than just accepting them as compliance overhead. Security in OT environments is not a project with a completion date. It's an ongoing practice. The threat environment changes. Attackers will develop new techniques. New vulnerabilities are discovered in industrial products. New threat actors direct attention toward critical infrastructure. The network changes. Equipment is replaced. Connectivity requirements evolve. Vendor relationships change. The regulatory environment changes. New standards are released. Compliance requirements are updated. What doesn't change is the need for engineers who understand both the process and the network, who can evaluate a firewall rule in terms of what it means for process control, who recognize a protocol weakness in terms of its operational consequences, who treat network security as part of the job alongside everything else they're responsible for. The knowledge from this course is the starting point. Apply it in your environment. Ask questions when something doesn't match what you'd expect. Push back when network configurations don't meet the standards you now know to expect. The physical world depends on control systems that are operated by people who understand both what they control and what they're connected to. Thank you for completing this course on networking fundamentals for OT engineers.